Hello everyone. In the last video we talked about how can we do the pre-processing into the 3D volumes for tumor segmentation or even for organ segmentation using the Monai framework that we talked about. It is a open source framework based on PyTorch. So this is the blog post about that video that we talked about. So you can, if you didn't watch it, so you can watch the video or read this blog post about. I am putting here all the explanation from the installation into all the code that we used. And now what we will do, we will do the same thing. We'll use always this Monai framework, which is this one, but we'll use it to do 3D volumes augmentation, because we know that always when we do deep learning, when we have a small amount of data, we need always to do augmentation. And for that, sometimes it's not that easy to do this augmentation in the 3D volumes. For that, I will show you how to use Monai framework to do it very easily. So we see that there is nothing different between what we did for the pre-process and here. For that, I didn't want to write the code with you step by steps because it will take time. But I just put the code here and I will explain it for you. So it will be easier and it will not take a long video as before we took 2 hours for the pre-processing. Okay, so here is the code that I will provide you after the video with this blog post that has the explanation. She's written explanation that we will use, and I don't know, you can look for the blog post, or you can directly take the code, and of course I will explain these lines of code in the video. So now let's get started. As you can see here, there is nothing that differentiates between when we did the pre-process and when we will do now this step, which is data augmentation, because there is nothing different. You can see that the first thing that we need to do is to import all these transforms that we will back to them after. I will leave this part after. Now the first thing here is to define the data from the training labels and data, and if you have for the validation you want to augment them as well, so you can put them here, or if you have a folder that has for the training and validation, and of course you will do the same thing here. In the last video, you will see, in the video of the pre-process, you will see that we talk about all these stuff and we went with them step by step. For that, I don't want to explain them another time. So all what we did here is to create we created a dictionary, Python dictionary, and we put all the data that we have with the corresponding label in each row of this dictionary. So there is nothing difficult in this part, but as I told you, if you didn't understand what we are doing here, so you can see the last video, or you can read the blog post about it, or the blog post for this video here. So, and the next step, which is this is what we did for the pre-process. When we did the pre-process, we used the same function. So we loaded the images with the labels, then we added a channel, as we said, for the different channels that we have, because we have foreground and background. So we need a channel for the foreground and channel for the background. This is the rule of this line. Then we did this spacing, etc., just to make all the pixels for all the patients with the same dimensions for the width and the height and the depth, because we have voxels, not pixels, sorry. So this line of code will do this pre-process. And for this one, we didn't talk about it, but it is not necessary. If you want to add it, okay. If you don't need it, you can leave it, because there are a lot of stuff that we can use and you can add that you find in the documentation, but not all of them are necessary. Okay, so the next part, which was this one here, this line scale intensity, this is what we use to scale the intensity to make the image visible. And finally, this final line, which was to convert the final transformed image or the final loaded image into a torch tensor, so that we can use it in the data loader and we can use it for the training using PyTorch, of course. Or if you will use TensorFlow, you need to convert it into a TensorFlow tensor. So now this is the new part that we will talk about. as you can see, there is nothing different than the normal, because this one we called it a original transform, because we are only doing the pre-process, so that we will leave the images or the patients as they are, only we will make them visible for the training. But in this part we call the generated transform, because all the transforms that we wanted to apply to generate a new synthetic patient, in that case we used them here. So there is two different ways that you can do this. There is three different ways that you can use. I used two of them and I will explain to you two of them, but the third one, if you want to use by yourself, so you can do it. But because if you will understand the two that I will explain, so it is easy to understand the third one. But because it will be only for Python developers to do this. So the first thing that I am saying here, because when we do the pre-process, when we do the augmentation to the data, we need to save them. So for what I used, in my case, I used two ways. The first one is applying the transforms, which are this one. I will go for them step by step, but now I am talking only about the ways how to apply these transforms. So the first one is to apply them during the training. So we will have always the same amount of data. So if you have 60 patients in your data set, so they will be always 60 patients in each epoch, but in each epoch they will be visible in another way. So in each epoch you will apply random transforms, so that in each epoch these same 60 patients will look in different way in each epoch. So I used this method and it was okay, it wasn't bad. So you can use this one. The second one is to generate this synthetic data and save them into one of your folders and add them with your datasets and use them after. So you will get a new amount of data, your 60 patients plus the synthetic patients that you generated. And the third one, and this second approach works okay as well for me. And the third one is to generate synthetic patients, but you will save them only in the RAM. So you will create an array or something and you save them as you do in when you use TensorFlow, because TensorFlow has a specific function that you will specify only how many times you want to multiply your data, and it will generate them and save them in a tensor. So you can do this here. There is no such function that do this, but you can create it by yourself. But this is the third way that I will not do in this video. So in this video I will talk only about the two first ones. The first one is to create the patients, to apply the transforms in each part, in each epoch. The second one is to generate patients and save them in your desktop or something, then use them in addition with your patients, with your 60 patients, for example. So now let's talk about the different transforms that you can, different transforms to augment your data that you can use, or they are available in Monai. So for now I am writing only three. The first one is the rand affine, which is random affine transformations. So they can be translations, or which is shifting, or they can be rotations and zooming. I think we will go to the documentation and we will see only this function rand affine, D for dictionary. We talked about this in the last video. So only this function can apply 2 or 3 different transforms at the same time. We'll see here. Here is the documentation of Monai. You will find a lot of transforms that I didn't talk about, because there are a lot of transforms that you can see. Maybe you need them all, or maybe you need only 2 or 3 of them. For that I didn't want to put all of them, but I will show you how you can find them. So now let's do Ctrl F and let's look for that transform, which is rand affine. D, like this. So this rand affine D, you can see that in the parameters there is the first thing is spatial size, which is the spatial size of your input images, and probability, what is the probability that you want to or we can say how many patients, what is the probability of the patients that you want them to be transformed. So it will be from 0 into 1. So 1 means that 100, all the patients you want them to be transformed, and depends to you. You can apply any number you want, and you can test them always, because all these transforms will happen randomly. So be careful with this random. You can generate and visualize your data and test them if they have been generated well or not. Then here there is rotation. You can apply rotation. All what you need to do is specify the number or the angle of the rotation here. This is the parameter. If you want to do a shear range, you can put it here, but I don't recommend you to do shear here, because for the medical images, if you do shear, you will lose all the information. But I don't know, it depends on your type of data. Then you can apply translation, and I think, yes, these are the different transforms that you can apply using only this function, which is rand affine d for the dictionary. And there are others, of course. There is, for example, flip d, like this. We'll go, for example, this one, flip, to do a flip if you want to flip your images, so you can do this. And of course the parameters, there are always the keys, which are for, if you are, because we have this parameter keys because we are working with the dictionaries. So when we work with dictionaries, we need to always to give the keys. So we want to apply this transform in the images only, or on the images and labels as well. So these keys here, these keys, because we talk about it in the pre-process video, but I am just clarifying it. So these keys will specify which type of data you want to apply this transform. So in our case, of course, it will be the images plus the labels. Then we have more than, I didn't use them all, but there are a lot of transforms that you can check them all here in the documentation. Now I will show you just few of them that I applied here to give you an example. But of course, if you need to apply more, you can see them and put the exact keys or the exact parameters in the parentheses there. So what I applied this rand affine d, but I used it only for the translation range. So I used this only to do translation or shifting if you want. So I put this number 10, which is, it will translate the patients randomly by 10, but not all of them. Sometimes, but in our case, I am doing probability equal 1, so maybe all of them, they will be translated by 10. Okay, then the next transform that I applied, which is rotate d, rand rotate d. So rotate, it, of course, it will do rotation, but we are always seeing that we have rand rotate, which is a random rotation. So in this case, with the angle that we will do rotation with, which is 10 degrees. So this is the case for applying rotation. And this is another one that I used, and it was useful for me, this transform, which is rand Gaussian noise. So we'll apply Gaussian noise to the images. So in this case, if you have overfitting or something, you can use this function to make the data a little bit difficult to handle. So in this case, your model will be robust with the clean data. For that, preferably you need to use some of these Gaussian noise to make your model very robust. So these are the only transforms that I used, but it depends to you. As I told you, you can apply these, or you can apply more than that. There are a lot of, you can add flip or any other type of transforms that you want. Now, this part is just the data loader. We talk about this as well. It is just this function dataset. It will take, or it will define the files or the patients that you have with their transforms. So here we will apply the original transform, just the pre-process on the same images, so that we will see the difference between the images, the normal images, and the synthetic patients with the same index. And the second one here, we call the generated dataset, because this will be the generated, these are the generated transforms. These transforms will apply them to the normal images, that the same images that we have here, or the same patients, and we will see them different than here, because here we applied some transform to generate new synthetic patients. And you can see here we have the data loader that will load the data for the same thing for the original and for the generated patients. Now this function first is just to pick the first item from the data loader. So when we do it first and we put data loader or original loader here, means that we will pick, or we will extract the first item, or the first image or first patient from the data loader, so that we can plot it here, as you can see. Now here this is we'll use the same thing here for the preprocess. I am always saying that because you will find all these explanations in the last videos. I will link in the description. So here are the different lines of code to do that, just to define a figure, then subplot it to apply. For us, we need only two parts in this figure. So we will see the original image and the synthetic image. And here is the same, this is the same patient, but this is always the same patient, but after that we apply the transforms. You can see all this noise here, which is from the Gaussian noise, and this is a rotation, as you can see, and the translation as well. So you can see that the same patient, but you can see that it looks like a different patient. So now it is the way that now we will talk about how can we use them. You can see that it is another patient. So now if you want to use the same patient for if you want to use the same patient for each the same number of patients, sorry, for each epoch, so you can use this, you can leave the program as it is. So only this data generator, it will in each epoch, when we will call this data loader, in each time it will apply this random affines or random transformations in each epoch. So in each call it will apply different transforms. So in this case, in each epoch you will have always the same number of patients, but looks in different way. But if you want to save them, because I told you I use two ways. If you want to save these synthetic data in your desktop and use them after, so in this case you will use the this function. This function, you can see we talk about it as well in the last video, in another last video that I will link also in this in the description. We talk about how can we convert a normal array into a nifti file, because we need to save them into nifti files, because to use them after, to use them in other training, so they have to be at the same type of data. So you will not have problem after that to load this tensors and the nifti files alone. So in this case you need to load them all together. For that, here is the function. What we did in the last video, when we just defined a numpy array, normal numpy array, then we converted it. The same thing here, but here we don't have a numpy array at first, because the image, it will be a torch tensor, because we said that this function here, after applying all the transforms here and here, we will convert the final patient into a torch tensor. So when we converted it for the data loader, it will have torch tensors. For that, if we want to save them, we need to take them here. As you can see, here is the tensor. Sorry. Here is the tensor that we have for the image. Then what we do, we just, here is for the image and this one for the label. And what we do, we just convert them into numpy arrays. So numpy, np for numpy dot array. So we will convert anything in the parameters into a numpy array. And we added this data type into float 32. And you can change all these parameters as well. It depends to you and your problem, because this is not just an example to show you how can you use Monai for this kind of problems. Now this is the first thing that you can do, and after converting them into a numpy array, you can use these functions that we talk about, which is nibabel.nifty, and it will convert this numpy array into a nifty file. After that, just to save them. Before that, we are doing this to create creating paths when we will put all these generated patients, because all here we have out, it is in the parameter that we will talk about after. In this out, we need to give the path where we want to save the images, or when we want to save these synthetic patients. Now after that, we created the patients, converted them into a numpy array and converting them into nifty files. Now we need to define we need to define the folders, or yes, the folders, one for the images and one for the labels. After that, we need to save them. But you can see here, if we don't have these, if these paths or these folders doesn't exist, just we are making sure that if they are not existing, we need to create them here. My OS that make dir, which means make directory, sorry. So in this case we will create folders if they don't exist. Now after doing all this, all what we need to do is nibabel.save, and we put here the volume and label, and of course all this stuff are just defining the final path, which is the path that we created, plus the name of the file, which is the generated passing or the passing generated, with the index, which is index 0, 2, 3 to the number of passings that you have, so that you will not you will have new number. You will not extract all the, or you will not duplicate all the passing that you have, because if you don't make a specific name for each passing, so you will have at the end only one passing, because it will compress it in each iteration of the loop or something like that. Now all this process will be for only one passing, as you can see, because we will take one volume, one label, convert them and save them. But for our case, we don't have one passing, we have more than that. For that we needed to create a loop that will go for all the passings, and of course we need to specify how many times we want to multiply our data. So if you have only 10 passings and you want to get 100 passings, for example, so you need to multiply your passings by 10. So you need to apply these affine transforms 10 times. So in this case we'll go from here until the up part, because this is the first easiest part that we will talk about. You can see here we are putting for index and passings in save loader. Save loader is this one, save loader, which is the data loader for the images that we want to save. And of course they are always the same here. You can see that it doesn't differentiate from this part that we put here, but we are putting it in the for loop, so that we'll call it in each iteration of this loop. So save dataset, then dataset we will define the training files with the generated transforms. Now after putting the files with their transforms, we will load them into the data loader, as you can see here. Now after loading them, we can take each passing or each synthetic passing from the data loader and save it. To save it, this is the function that we was talking about, save nifty. This is save nifty. This is the function save nifty. It will take in the parameters the in image, the in label, the output path, and the index of the image, which is which will give the index or the name of the passing. So if we have the first passing, so it will passing generated 1, passing generated 2, etc., etc., until the number of passing that you have. Now, as I told you, we have this function save nifty. Will save one passing, but when we put it in a for loop here, it will save all the passing that we have in the data loader. So when it will save all the passings, this one is, if we leave only this part, it will be only one iteration, or it will multiply the data by 1. You will have your 60 passings, for example, plus another 60. So that's it. But if you want to do it multiple times, we need to add another for loop that will control how many times you want to multiply your data. For that case, you can see for e in range. So this range we have number of runs. So number of runs is the number of how you want to multiply your new data. So when we do this, you can see that here we have generated data. We are creating a folder, of course, because when we will generate data for 10 times, so we need to put them in 10 folders, for example, and after that you can put them together. This is that was just my idea of doing this work. So if I want to multiply it by 10, so I create 10 folders, and in each folder I put the data that I generated in that iteration. So I create the folder. For example, here it will be, when we are saying in range or number of runs, so here it will be generated 0, 1, 2, 3 into 9. It will be 10 times. So we create here the folder, because here we are just defining it. Here we have my make directory. So we create the folder exactly. Then we put we create here, and we put the transforms with their files, which are the training files. Then we do the data loader. After that, we do the saving part for all the data that we have in the data loader. So all that iteration, it will save one time or it will multiply your data by one time, and second iteration it will be 2 times, 3 times, 4 times, etc. So it depends to the number that you will put here. Number of runs is the number of how many times you want to multiply your data. So after doing this, you will create new data. But I want to recommend you something. Why I use this, I didn't use the method that save the images only in the RAM, or say, yes, I didn't want to use this part, because you will see that when you apply these affine transformations or random transformations, it will sometimes generate some Gaussians or some shapes that doesn't exist in reality, something randomly that it doesn't exist, because for some normal images it doesn't make big changes. But in medical imaging, if you will apply rotation with translation in the wrong way, you will create something doesn't look at a patient or doesn't look at a human body. So this kind of patient you don't need, and it will affect your training. For that, I choose to do this way, to save them in my folder and check them by myself, check them if all the patients have been generated well. And to be honest, I found a lot of patients that have been generated in shapes that I don't need in my training, so I needed to delete them manually. So if you will do all this part automatically, which means create the synthetic patients, save them in the RAM, so you will get this problem, which is generating patients or random patient that doesn't exist. So I recommend you to do this way, which is save the patients in your folder, then check them by yourself if all the patients have been generated well. Then of course you can use them for your training. So that was for this video. You can find all the you can find here the explanation of this code and what we did in this part, and of course I will leave the code for this notebook in GitHub, and I will give you the link as well, and the same thing for the transforms. I will leave this link in the description, so you can go here and search for any type of transform that you want to apply. So you need to search for it here and see which are the parameters that you need for that specific transform, and use them in this part, which is, for example, here we have generated transform. So you can add it here and put the different parameters and use it. And of course you have always to verify what you are generating, because I told you that in medical images you will generate something that doesn't exist. So always you need to verify by yourself what your program generated. After that you can use them for your training in deep learning. So that was for this video, and I see you in the next video. If you did enjoy this video, don't forget to like and subscribe to the channel to see more stuff about Python, deep learning, machine learning, medical imaging, etc. So I see you in the next video. Bye bye.